We're going to be looking into basic trig identities, and some of these you have on your foldable, and then we'll get to some that you don't. The reciprocal functions, the reciprocal identities you do have. So basically what it's saying is if tangent of theta is equal to c, then find cotangent of theta. Well, because cotangent is the reciprocal of tangent, then that means that the cotangent of theta is going to equal 1 over c. If sine of theta is equal to square root of 3 over 2, find cosecant of theta. Cosecant is the reciprocal of sine, so that means cosecant of theta is going to equal 1 over square root of 3 over 2, which is really just going to be 2 over square root of 3. But remember, you have to rationalize the denominator, and I get cosecant of theta is equal to 2 square root of 3 over 3. And the last one, cosine is negative 1/2. Then the secant, which is its reciprocal function, is going to be, basically it's just the reciprocal of the cosine, so it's going to be negative 2. The tangent and cotangent are quotient identities. So because tangent is sine over cosine, and here I'm given what sine is equal to and what cosine is equal to, so I can say tangent of theta is equal to sine of theta over cosine of theta. So in this case it's going to be tangent of theta is equal to 3 over 5 divided by negative 4 over 5. So I have 3 over 5 times negative 5 over 4. My 5's will cancel out, and I have tangent of theta is equal to negative 3 over 4. To do the cotangent, it's going to be cosine over sine. So that's going to be negative 4 over 5 over 3 over 5, which is going to be negative 4 over 5 times 5 over 3. Again, my 5's will cancel out, and I'm left with negative 4 over 3. So cotangent is equal to negative 4 over 3. Okay, to get this next identity, we're going to take the unit circle, and we're going to take one of the triangles on it, and I'm going to show you, remember that, so this is my x value, this is my y value. So if I have x squared plus y squared, that's going to equal c squared. And if you remember that the hypotenuse in these is the radius, so that means it's going to equal 1. Well, I also know that on the unit circle, sine of theta is equal to x. So, and I'm sorry, sine of theta is equal to y, and cosine of theta is equal to x. So what I can do is I can replace these. I'm actually going to write the sine first. So y squared is going to be, let me do this, sine theta squared. X squared is going to be cosine of theta squared, and that's equal to 1. And that's my first trig function, or that's my first Pythagorean identity is what this is called. And so I'm going to get 2 more of those, and what I'm going to do is I'm going to divide everything by sine squared theta. So divide everything by sine squared. And that's okay because I'm doing it to everything. It still keeps the equation true. So sine squared theta over sine squared theta, that becomes 1. And then that's going to be plus cosine squared theta over sine squared theta. Well, that's cosine over sine, which is cotangent. But because they're squared, it's squared. And then 1 over sine is going to be cosecant. And so this is now my second Pythagorean identity. And my third one, I'm still going to take this first one. But now I'm going to divide everything by cosine squared. So I'm left with sine over cosine, which is tangent. Cosine over cosine is 1. Cosine squared over cosine squared is 1. And 1 over cosine is secant. So this is now my third identity. So I have these three identities now that I can use. Add these to your foldable. On the left side there is a spot for Pythagorean. And that's where these are going to go. These are my Pythagorean identities. And so I can use these identities to solve some equations. Or to find other parts to it. Right now is all we're going to do. I have sine theta is equal to 4 over 5, and I'm looking to find cosine of theta. So because I'm given the sine of theta, I'm going to use the Pythagorean identity that has the sine in it, which is that first one. So I'm going to replace this sine squared theta with 4 over 5. Now that's just sine of theta, so to get the sine of theta squared, I need to square that. Plus cosine squared is equal to 1. So when I square this, that becomes 16 over 25 plus cosine squared is equal to 1. If I subtract the 16 over 25, I get cosine squared theta is equal to, and this would be 25 over 25, right? So that's going to become 9 over 25. And what I can do now, I can square root both sides, and I get cosine of theta is equal to plus or minus 3 over 5. Okay, and I didn't write this second part, but the second part says where the terminal side lies in quadrant 2. Well, which one of these would lie in quadrant 2 is when the cosine is negative, so that means that cosine of theta is going to equal negative 3/5. And so now to find the tangent, I don't have to use the Pythagorean identities. I could, but I'm going to use, I have the cosine, I have the sine, so it's going to be sine of theta divided by cosine of theta. So I get 4 over 5 times negative 5 over 3. My 5's cancel out, and I have tangent of theta equals negative 4 over 3. Okay, so for this next one, find sine of theta and cosine of theta when I'm given tangent of theta is equal to 3 over 4. And the terminal side of theta lies in quadrant 3. And that's an important part after you find, you're going to find 2, and you got to figure out which one it is. So because I'm given the tangent, I'm going to use the identity that has tangent. So I have 3 over 4 squared plus 1 is equal to secant squared. So 3 over 4 squared becomes 9 over 16 plus 1. So that's going to be 25 over 16. And when I take the square root of both sides, I get secant theta is equal to 5 over 4. But remember, it's plus or minus. And secant is the reciprocal function of cosine. So that means cosine of theta is equal to plus or minus 4 over 5. And what is cosine in quadrant 3? Cosine is negative in quadrant 3, so that means cosine of theta is equal to negative 4 over 5. So then I'm going to use this information in order to find sine. So I'm going to go back to that original, the first identity, and cosine squared is negative 4 over 5 squared is equal to 1. So I have sine squared plus 16 over 25 is equal to 1. When I subtract 16 over 25, I get sine squared is equal to 9 over 25, take the square roots, and sine of theta is equal to plus or minus 3 over 5. And in quadrant 3, sine is negative, so that means sine of theta is equal to negative 3 over 5. Okay, so this is my last one, and I'm asked to multiply 1 minus cosine of theta times 1 plus cosine of theta. And if you notice, this is a difference of squares. We'll multiply it all out. 1 times 1 is 1. Positive cosine theta, negative cosine theta, but because it's a different squares, those are going to cancel out. And then this becomes negative cosine theta squared. So I get 1 minus cosine theta squared. And which Pythagorean identity can I refer this to is sine squared theta plus cosine squared is equal to 1. And if you notice, if I subtract cosine squared theta, I get sine squared is equal to 1 minus cosine squared. So that means that this 1 minus cosine squared times 1 plus cosine squared is equal to sine squared of theta. All right, so that's it. And the assignment will be on Wednesday.